My name is Dennis Nash. I'm the president of Control Station, a leading provider of process diagnostic and optimization solutions. I'm joined today by Dr. Bob Rice. Dr. Rice heads Control Station's engineering team. He is a frequent presenter at industry conferences and is a recognized expert in regulatory and multivariable control. Without further delay, Dr. Rice, the stage is now yours.
Excellent, Dennis. Thanks for the introduction. So today what we're going to cover is process analytics, and specifically we're going to talk about what your plant's data is trying to tell you. All right, so we're going to learn a little bit about regulatory controller performance metrics and how you can actually extract useful information out of your plant's data sources, data historians, to actually get some real value. So this talk has a couple of different areas. We're going to start a little bit with a background to Control Station, and then we're going to hop right in and talk about the motivation behind process analytics, controller analytics, and then we're going to have a discussion regarding the difference between controller health and controller performance, and which expands to plant performance versus plant health. We're going to talk a little bit about the perspective of the data and who's looking in on the data, who's accountable for the data, who's creating actions from the data, and how that changes depending on what level of your facility you're at. Then we're going to dive in and talk a little bit about specific KPIs and metrics, distinguish between kind of the micro, the very precise KPIs and metrics, and how you would roll those up into more macro views, macro metrics that are composite values that you can start to roll up and start to look across multiple facilities and assets and so forth. So we're going to kind of lay the groundwork for what analytics are important and what they can tell you, and then we're going to talk about some of the opportunities and challenges, because none of this is necessarily free or easy, right? You have to actually put in effort and time to make analytics valuable. So we're going to talk about some of the challenges that are out there and some of the opportunities that come out of putting forth the effort here. Then I'm going to end this with a call to action. I'm going to ask everybody to go out and do something that'll have a meaningful impact on your site, and then we'll go ahead and stick around and answer any questions that you may have for the remainder of the time. So Control Station, as Dennis had talked about earlier, is the leading platform independent provider of process analytics and optimization solutions. We were founded a number of years ago at the University of Connecticut and have been innovating our software for over 32 years at this point. We have installations in 71 countries, and we support about 50% of the manufacturers on the Fortune 500 list. So let's talk a little bit about motivation. Why do we care about controller performance, right? We're all running our plants. Our plants are producing our products. They're doing their job, right? There was an analysis done a number of years ago by Michael Brown, and this data was published 20 years ago at this point. And the interesting metric that I like to pull out of more than anything else is this idea of 20% of controllers are not properly configured to meet their objectives. Their narratives, their control structures are not actually adequately defined to actually match what their goals and objectives are. Then we look at this number right here, and this is the one that I'm really after. 30% of your controllers are actually operated in manual mode. That means you've gone through all the work of building your automation, programming your DCS, putting your PID controllers in, and 30% of them aren't even being used. And that's an interesting statistic. That's a large amount of your assets that are not in automatic, that are requiring operators to actually go out and manually manipulate the process to maintain your targets and so forth, right? And that's not a very efficient way to operate. Granted, this was 20 years ago at this point, back in 2003. If we take a look a little bit forward and we actually take a amount of data from our handbook, right, and take a look at the numbers that we have out in the field, and this is an audit of 17 to 18,000 controllers across a number of different types of facilities, whether they're greenfield, they're brownfield facilities, sites that are small, sites that are large, sites that have a large presence on a process optimization team, so they have a very strong continuous improvement initiatives, and these are other sites where maybe there isn't any local support, right? So this is a pretty good cross section. And what I found interesting, again, this is data that was taken within the last year or so. We still run around 20%, 19% of controllers are still operating in the wrong mode, right? So over 20 years, we've gotten a little bit better, but the opportunity is still there. That means that you have all these assets that are out there that aren't even running in the proper control mode. You've got loops that are in manual. You have all this automation that is not doing its job, right? We still show a fair bit of loops have cycles and oscillations in them. You know, a positive aspect of some of our analysis is the amount of loops that are actually displaying poor controller performance due to valve issues, valve diction, stuff like that. That number has actually decreased a bit. And a lot of that is because of smart instrumentation. You know, we're not running, you know, everything on pneumatic butterfly valves. We actually have got digital positioners in place, and that really improves performance and control. We still show quite a bit of error associated with loops. You know, something like 26% of controllers exhibit more than 5% of range of error, right? So the variability is still there. This is basically telling me that there's opportunity out there. So whether or not your plant is brand new and you've had a lot of optimization efforts and initiatives in place, or your plant's been there for 100 years and it's been working, there's always opportunity there, right? But you got to get to that data. And the truth is, we are data rich and information poor, right? We have so much data being collected at sites, right? We're starting to really get into sites that have a very large data historian presence, even if they're a small mill or a small pharmaceutical plant or a small chemical, a batch chemical company with maybe only a couple of reactors. They still may be monitoring thousands and thousands of tags. You know, not just your traditional process data, right? Your temperatures, your flows, your valve positions, stuff like that. But you're actually starting to historize alarms and events. You're starting to historize, you know, incoming factors like energy cost, performance data, controller information and configuration data, network throughput, widgets and energy consumption, and a whole bunch of information across your entire site. And all that data is being built up into this big wave. And you can either write it and start to extract data out of it, or you're going to be crushed by it because you're not taking advantage of it, and it's going to overwhelm you, and you're going to end up with not a lot of value out of all of that investment, right? So we want to make sure that when you're out there, you're riding that wave of data, you're taking that information and you're generating value out of it. And when you think about controller performance, plant performance, you know, what is that data telling you? It's telling you a couple of things. It's telling you how well your plant is performing, right? How well it's behaving. And one of the things that I've really come to realize in the last few years is health and performance, they're not interchangeable words, right? You can have a healthy plant and a non-high performing plant, right? Health is essentially how well all your equipment is behaving. You know, all your controllers in automatic, are your valves behaving right? Are your reactors behaving as expected, right? They work, right? Does the system work or does it not work? Is it offline or is it running? That's related to the health of a system, of a loop, of an asset, of a plant, right? Is it actually working? Right? And that's really important. And that's truly the first step of any kind of continuous improvement initiatives is you have to go out and do some analysis to say, does this work? Does this piece of equipment work? Does this valve work? Does this sensor work? Does it actually do its job? Once you've got everything working, now you can actually go and start focusing on things like performance. How well is it performing? Is it introducing less or more variability into the process? Are we able to tighten control and operate closer to constraints? We start doing optimization or advanced process control and really start pushing and driving your process to be as, you know, high performing as possible, right? It's the difference between driving, you know, a Honda Accord and a Ferrari, right? They're both great vehicles, right? And the Honda Accord is a great, healthy car, not a high performance car, right? The Ferrari is high performance and hopefully it's healthy, right? But what do we know about Ferraris? Their reliability is always a little bit sketchy. So the higher performing you get your things your plants, your assets, your loops to behave, the more you have to worry about the health, the more you have to keep in monitoring to make sure that all of those assets are performing well, right? And I really like to differentiate those things because the KPIs, the metrics, and the conclusions that you draw really depend on, are you going after health? Are you going after performance? And you can't go after performance until you've hit the health. So to be able to start understanding performance and health, we have to really start to understand the micro and the macro performance of your site, your fleet, your area, and et cetera, right? And if you kind of think about the hierarchy, you've got instrumentation, you've got control loops, you've got area, which has a bunch of control loops, you've got sites, you've got fleets, you've got kind of this hierarchy of information. When you're starting to look at the performance or the health of these different areas of the plant, you have to take into account this idea of ownership and accountability, right? Who owns the performance? Who owns the health? And who's accountable for it, right? Those aren't always the same people, right? Ownership could be at the individual site level, or it could be at the corporate level, right? Generally, ownership is higher level. It's at the management level. It's at the corporate level. But the individual sites, the engineers, the technicians, they are accountable to assure that each one of these things are actually behaving well, right? And so they are different depending on how you define them, and they generally are at different levels, right? And you could argue, well, is it accountability? Is the corporate accountability, and then the site owns it? That's fine, right? But you got to make sure you define and understand the differences between those, right? Because you need to have both sides of that. So you've defined the idea of performance and health, and you've defined the idea of accountability and ownership, and that people need to own these metrics. Well, let's start to define what are the things we actually care about. Now, this talk is not going to go into, the 20 or 30 different KPIs and metrics that you can use to track the performance of all your PID controllers. I just want to talk about kind of the basic buckets or groups of kind of what I'll call micro controller KPIs or primary controller KPIs, which are things that are looking at very specific characteristics, right? Things like variance, right? What is the variance of a controller? What's the variance of a process variable? What's the variance of your piece of equipment? What's the effort, right? How hard is something working to maintain control? How hard is a piece of equipment working to maintain control, right? Is your steam system working, twice as hard today as it was yesterday? Are your valves moving around twice as much, right? Is everything kind of, requiring a lot more effort to maintain that low variance? When you think about utilization, and this can actually kind of relate back to things like OEE and other things where it's like, how often is the controller actually being asked and allowed to do its job? Looking at things like, is it in the right mode? Is it not constrained? Is it, free to perform the control that it's being asked to, right? How is it being actually utilized? And then we look for maybe specific patterns, right? Are you looking for oscillation or valve issues or tuning issues? You're looking at behavior. Now, these four categories and buckets, quite frankly, are your kind of manual approach for looking at things, right? When you go and approach an issue where you're trying to troubleshoot something, right? Your first process, you're going to start throwing up some trends. You're going to start looking at data, and you're going to look at, oh, how much variance is there? Are things moving around too much? Is the controller in the right mode? Is it oscillating? Do I have a valve? You're kind of mentally going through the checklist yourself, looking at these things. KPIs are just, mathematical, analytical equations that can go through and give you, instead of that kind of qualitative description of a process, that quantitative measure, so you can measure and track these things, right? Because once you have these individual micro KPIs, you can start to expand them, right? You can take those micro KPIs and start to combine them into more macro values. So you're not looking at one specific thing, you're looking at the characteristic as a whole of a control loop. And there's a couple of different ways to do that. The one I'm going to just talk about quickly in this talk is what we'll call the overall controller effectiveness, right? So we're looking at the health of a piece of equipment, right? We're looking at the health of a plant, the health of a loop, and the overall controller effectiveness is essentially cherry picking a couple of these KPIs, putting it together to give you some value. So instead of having to look at 20 different things, let's look at one thing. Let's look at a single value. And this overall controller effectiveness is a very useful way of simplifying the data. You could also do things like looking at overall health of a loop, or looking at, valve health or mechanical health or tuning health, and you can combine these these micro KPIs into, more macro values. So instead of looking at one thing, you combine multiple to create it into a single value that is a little bit more meaningful than the individuals, right? And so if we think a little bit through the idea of controller effectiveness, right? And again, I'm just going to take a couple of these metrics and I'm going to expand upon them and tell you why you can do this, right? Overall controller effectiveness is essentially expanding on the idea of OEE, right? Overall equipment effectiveness, and kind of applying it to controllers. And the idea behind this is we want to come up with a single value that is easy to understand, easy to interpret, easy to roll up, that you can, move higher and higher within your analytics platform. And this is a simple one, right? This can be very easily calculated. It's the percentage of time that you're in automatic or cascade or whatever mode you're at, right? It's the percentage of time you're in the normal controller mode for that particular application, whether it's cascade or remote set point, APC, whatnot, right? So it's actually in the right mode. You multiply that by the percentage of time that your controller's free to move. It's not constrained, right? So instead of, looking at the times when you're at 100% or 0% you're saturated, when you're like that, your controller has no real control over the system, right? It's basically locked at upper and lower. It's not doing anything, right? And so the controller is not effective in that range. So we only look at the data when we're not constrained. So we take that time in normal times the time that we're not constrained or we're able to do the job, multiplied by this third factor, which is time in control, right? Now, what is time in control? Well, it depends, on the type of application or the metrics and KPIs. And I'll give you a couple of examples here on the next slide. But essentially, time in control is the percentage of time the controller is performing within tolerances without excessive movement, right? Are you within a certain target around set point? I'm plus and minus, 2 degrees C around my target, right? And I'm not moving my control valve too much. I'm actually behaving well. By taking this number and multiplying these three numbers together, we end up with an overall controller effectiveness that is very sensitive to changes in performance and behavior, right? And so you will have, if everything's behaving well, I'm not constrained, I'm in normal, right? Everything's there, you're 100%. But as soon as you start to, constrain your output, or maybe you're not in the right mode, or you're starting to valve, starting to move around, that overall controller effectiveness will dip, and it'll actually dip pretty quickly, right? And that's what we want to see. We want to see numbers that are healthy and then start to dive quickly, so we can see these troublemakers, these changes in behavior, so we can go and investigate. Additionally, then those numbers can be aggregated together, right, to get a much more macro view. So let's go ahead and take a look at an individual piece of the overall controller effectiveness. And when I say piece, I mean on one particular loop. And then we'll go ahead and expand that out to kind of the more macro style view. So if we take a look at a loop here, and this is just a level controller for a site, and let's be honest, this wasn't a level controller that was, the operators were freaking out about, that was causing the unit to shut down, that was causing massive problems, right? But when we start to look at it from an OCE standpoint, we can see we're being limited. And we're being limited in a couple of different ways. If you look at the data, this is actually the raw process data in this bottom trace here. The bottom trace here is the controller output, or where the valve is operating. The values up here are the process variable, the level in this case, and the target set point. And you can see we're tracking that set point perfectly fine, right? We're within some range, and hey, it's a level loop. As long as we're close, I'm good, right? The challenge that we had with this level controller, the thing that we actually realized pretty quickly, is this level controller is cascaded to a flow, and this poor flow controller is being beaten up by having its value, go between 0 and 50% constantly. And it's a hard thing for these ratio controllers to keep up with. It was doing the job, but it was working far harder than it needed to, right? And so if we take a look at the OCE for this, right, we can see that we are constrained quite a significant amount of time. So we're spending close to 60% of the time unconstrained, or sorry, uh, constrained at 0, right? And so 40% of the time we are free to move, right? Which is not very much. We can see that there are slices on the trend up here where the deviation or the variability from set point is we're right on the mark of where we're finding to be unacceptable, right? We're close enough where maybe the operator's not caring so much. We got a couple of times when the performance was pretty poor, right? And we're deviating high away. We can see our output travel, which is the number of full strokes per hour, the amount of movement on a control valve. It's higher than average. And we take all these numbers and we end up with an OCE that's pretty low. So we have an overall controller effectiveness of 25%, and it's really dinging the health. We go and we tune the loop and we fix it, right? And we can see that the OCE gets a lot better afterwards. Why? Well, because our valve isn't moving around nearly as much, we're no longer saturated, and our average error is far closer to our target. So the OCE is a very nice number, right? And what's kind of interesting again is this isn't a loop that was the highest on the priority list for operators to correct, but it had a really poor OCE that allowed us to go and see that. We went and corrected it, OCE got better, right? But that's one loop, right? And so if you think about the kind of the ownership or the accountability at the very micro level, this is a metric that tells the person at the site, I need to go look here and I need to go fix this one asset, right? And I'm going to go and tune the loop. But you need to be able to take this information and roll it up, because ultimately what we're after is the ability to define health and performance across areas and sites and plants, right? And so then you take that single metric and you can average it to an area of the plant. Maybe you monitor it across all of the plant, right? Maybe you'd have it across your entire fleet. And now you can start to say, well, fleet to fleet, site to site, area to area. How is my overall controller effectiveness? Where do I need to put initiatives, right? Where do I need to put some attention? And so you need to make sure that when you're taking this data from your plant, that the plant is telling you this information, that you can roll it up and you can start doing these KPIs, this analysis site to site. So how do you start something like this? Where do you begin? Well, you can follow a couple of different approaches. This is just kind of a simple approach, but you don't just jump in at the end at the metrics. You got to start at the beginning, right? You have to identify, what are the loops? How many controllers does my site have? Are there controllers that not in use? You have to do this kind of rationalization aspect of it. You have to define the accountability. Who is actually accountable for this? Who cares whether the OCE is high or low or the health is high or low, right? Then you have to start configuring this information, whether you're using controller monitoring tools or other analytic tools. You got to configure your historian. You got to collect your data. You got to define your targets, right? Then you got to define the ownership of this, right? You got to make sure that somebody owns this particular process. Then you have to start to refine your data. You got to cleanse the data. When is the data good? When is it bad? Start to define states and conditions. What's startup? What's runtime? Are there different recipes, different batches? How do those impact the OCE? How can you expand those conditions and states, right? Once you've built all of this, then you can start to run your model, run your process, kind of run by exception. Well-designed data brings troublemakers to the top of the list, right? So once everything is well-designed, you can really start to say, oh, here's a low-performing loop, here's a poor health loop, and you can actually kind of start to build the process here. And so now you can start to proactively monitor these systems, and whether that's control room operators, global engineers, managers, you can kind of own that. My other piece of advice here, start simple. You don't have to take and boil the ocean with 1,000 different KPIs and metrics. Start with ones that provide very quick, actionable information, right? I'm going to be honest, the percent time in normal, it's a great place to start. It's one everyone understands, and it's the one that's actually going to reveal issues very, very quickly. You're going to find controllers that are in manual mode because an instrument was supposed to be replaced, a valve is broken, or the operators run it that way. You're going to start putting controllers in automatic and start to quickly realize that there's probably some instrumentation or mechanical issues that have to be corrected. It's a great number to start. And you can really start to track and make some positive changes if you focus on 1, 2, or 3 kind of simple numbers. Some of the challenges, right? This isn't just to go out and do it solo and do it by yourself. You need to make sure that there's accountability, right? I've used that word ownership and accountability a lot because that is one of the major challenges with doing any analytics project. You need to make sure that, site to site, that you do have standards, right? So if you're looking at multiple site locations, you want to make sure your fleet is standardized. You're looking at the same things. You're comparing apples to apples, right? You need to make sure that you have the time to do the training of the engineering staff. If you've got remote sites, you got to deal with network reliability and availability. And if your site's 100 years old, right, you have to make sure you take that into account, right? Some of the advantages of doing kind of the corporate style, the central bases, you can start to really leverage the central data center cloud-based style. So you can start to bring the data up. You can create these standards. You can leverage central exports, whether the corporate team or the outsourced, right? And so no site gets left behind, right? All the sites get to be brought up together. And so what is your plant's data telling you, right? It can tell you the health. It can tell you the performance, but you have to listen. You have to have some accountability and you have to have ownership to be able to drive this data in, to build the project, to be able to say, here's how healthy my plant is, and here's by area, by site, by fleet, to be able to really give you the information. So here's a simple call to action, right? Identify one metric at your site that impacts the health or performance and start tracking it. Put it in Pi, put it in your historian, put it in Wonderware. Track it, on a couple times a day to be able to pull that number, to be able to say, okay, this is the percentage of time my controller is in automatic. This is the number of widgets per hour I'm doing. Whatever it is, take that number, right, and start tracking it, storing it, and archiving it as best you can. Then fix two things. Try to find something that impacts that metric and make changes, whether they're small or large. Just do something to have a positive impact. Track that metric for 3 weeks as you improve things, right? You will see numbers get better. That becomes your success. You always want to start small, kind of build that nice little success story, and then expand those ideas out to be able to say, here's all the information that my plant is telling me. Okay. I know that's a lot of material to cover in a very short period of time, and I know I've gone a bit longer than what I've needed to, but I'm more than happy to answer any questions that you may have.
Bravo. Thank you, Bob. Some great remarks. We did have a couple of questions that came in through the chat box, and I'll start with the first one. This question reads, which organizational level typically drives this type of initiative? Is it at the corporate or at the site level? Do you have some thoughts on that, Bob?
It's a great question. And like most things in life, it depends, right? It depends on who owns that kind of continuous improvement initiatives. I've found that a lot of corporate-driven initiatives will fail unless you have individual site buy-in. And so these types of programs really have to have that kind of two-pronged approach where you have a local site champion who is the either accountable or owns the process, and then you have the corporate liaison, which is the other half of it, right? And they have to work together to make sure that these types of programs are brought out to fruition, right? So you kind of have to have both levels of them, and I've seen both the site and the corporate path succeed as long as they work together.
Okay. A second question that was put forward was pretty pointed in terms of what are the benefits you and Control Station are seeing from this type of data analysis. There's a lot to that one. You have time for that?
Yeah, I'll do my best. I mean, the benefits are, if you're monitoring things, you can track them and you can show improvement. And we've had sites and customers deploy analytics across their fleet, and they've seen some significant improvement in their efficiencies, right? And I'll just give a simple example where we had a customer who would go out and do a ton of initiatives at an individual site, do loop tuning, loop optimization, put everything in auto and leave, and then over the course of 3 or 4 months, everything ends up back into manual again, and they come out again and they do all that work again, and it's just kind of this revolving door, right? So by putting in monitoring and tracking, they were able to actually sustain their loops in automatic, 95% of the time, all the time. And so you no longer have those kind of drops in performance. And they saw some significant improvements there, right? We've had other customers who have gone through and done kind of steam and temperature analysis and tune and did optimization of loops, and they were able to, decrease some of their cooling systems a few degrees and save energy, so they're not using as much heat in certain areas of their system. And the dollars can be there, but you don't know about the dollars until you start tracking them. And so the benefits are there, but you have to be able to start tracking them to be able to get to the benefits themselves.
Well, that's great. We have run a little beyond the scheduled 30 minutes for today's session. On behalf of Dr. Rice, myself, and all of the team here at Control Station, I want to thank everyone for joining us today. A copy of Dr. Rice's presentation will be distributed to all of the registered participants.